slowly and gradually uh, in the mechanics of machine we are leading toward the topics which are more practical in nature. So from now onwards we will have a series of lectures on mechanisms referred to as belts, chains and ropes. So all these are the elements for power transmission, and very specifically the today topic of discussion is flat open belt arrangement. How to define the belt? Basically, belt is a loop of flexible material used to link two or more rotating shafts, and this linkage is made mechanically. So belts are looped over the pulleys to transmit power from driver shaft to the driven shaft. A classical example is available in your homes. The pump, the water pump. What is actually happening? There is a motor which generates power. The motor generates power and power is available on the shaft. At the opposite side there is a pump which has some mechanism, maybe the piston arrangement or the centrifugal arrangement. Whatever the arrangement is, the purpose is to push water from the low head to the higher head. So basically it's increasing the pressure. So we have two systems, a motor which produces power and power is available on the shaft, pump which need power to transmit water from one head, from lower head to higher head. So both has the shafts. So what we will do, we mount pulleys over the shaft and then the belt will loop around both the pulleys. An interesting thing about this mechanism is this belt is flexible. The remaining components are rigid. For example, shaft, pulley, shaft, pulley. So both the shafts and pulley arrangements, they are rigid. But interesting thing is this belt is totally flexible. And there are two types of belts which we are going to discuss. The flat belt, which has a square cross section, and the V belt, whose cross section is trapezoidal. The very first task for the flat open belt arrangement is to find angular velocity ratio, and this angular velocity ratio is for the condition without slip. What is actually happening that we have two shafts, shaft number 1, shaft number 2. Shaft number 1 is the shaft where power is available, and we have to transmit this power from shaft number 1 to shaft number 2. Pulley mounted on shaft number 1 is called driver pulley because there is a source of power which is going to transmit power from shaft 1 to shaft 2 via pulleys and belt arrangement. Shaft number 2 is a shaft which is the recipient shaft of the power produced by shaft number 1. Because this is a recipient shaft, this means this pulley is recipient too. So what is actually happening? This shaft is producing power which is transmitted to this pulley, and then this pulley moves this belt, and once this belt is moved, because this belt is looped over the second belt, second pulley, so it tends to move the pulley number 2. because this pulley is moved or driven by this belt, so it's called driven pulley. So the nomenclature or different terminologies that we are using here are: D1 is the diameter of driver pulley, N1 is the RPM of driver pulley, omega 1 is the angular velocity of driver pulley, D2 is the diameter of the driven pulley, N2 is the RPM of the driven pulley, omega 2 is the angular velocity of driven pulley. There are two sides of this type of arrangement. One is called tight side and the other is called slack side. How these two sides are defined? It's very easy. Just you have to use your imagination. You're observing that this is the driver pulley, which is going to transmit power to the belt, and then via this belt power is transmitted to the driven pulley. The rotation of driver pulley and the driven pulley in this type of arrangement is same. Means if the driver pulley is rotating counterclockwise, then the driven pulley will also rotate counterclockwise. So if this driver pulley is rotating, then this pulley will pull this belt. Imagine if this pulley is rotating and this belt is wrapped over it, then by rotation action this belt will be pulled, whereas this side, on the other side, this pulley is pushing this belt. So the side where there is pulling mechanism is referred to as tight side, and there will be more tension as compared to the side which is the pushing side. So the tight side is defined as the side where the belt is pulled by the driver pulley, and the slack side is defined where the belt is pushed by the pulley, the driver pulley. And T1 is defined as tension in the tight side, and T2 is defined as a tension in slack side. Similarly, V1 is the velocity of tight side, and V2 is the velocity of slack side. Here there is a very important point that I have to mention. The tension in tight side and tension in the slack side, they will be different. Normally tension in the tight side is always more than the tension in slack side, or T1 is always more than T2. However, there is no slip condition, means if this pulley is making angular motion or rotation, then this pulley is pushing this belt and pulling this belt without any slip, and this is the actually ideal condition. In ideal condition, we assume there is no slip between pulley and the belt. Therefore, the velocity V1 will be equal to V2. The target of this slide is to find angular velocity ratio. So we have to focus on omega 1 and omega 2. Let's proceed and find this ratio. So omega 1 is referred to as angular velocity of driver pulley, and from our basic knowledge it is equal to 2 pi multiplied by the RPM of driver pulley divided by 60, and the units will be radian per second. Similarly, omega 2 is defined as 2 pi into RPM of driven pulley divided by 60, and the units will be same, radian per second. If we divide omega 1 by omega 2, then 2 pi by 60 will be cancelled out, and the final relation that we will have is omega 1 by omega 2 is equal to RPM 1 by RPM 2. So this was our target, and I will request you to please memorize this formula, which will help you to calculate the missing term in the problems. As I earlier discussed, the velocity of belt of tight side is referred to as V1, and velocity of belt at slack side is defined as V2. Ideally, if there is no slip, then velocity V1 will be equal to velocity V2. We know that the V1 is equal to pi into diameter of the belt into the RPM of the belt at the driver pulley, and V2 is equal to pi into diameter of driven pulley into the RPM of driven pulley. So if we equate V1 equal to V2, then their right hand sides will come as here. Pi is common on body term, so they will be cancelled out, and if we move the n to the numerator for the other side, then we will have a final relationship such as d1 by d2 is equal to n2 by n1. What this means? This means smaller diameter pulley will have higher speed of rotation. So again I will repeat, the diameter ratio of the diameter of the smaller pulley to the larger pulley will be equal to the RPM of larger pulley divided by the RPM of smaller pulley, and this relationship means the smaller diameter pulley will have the higher speed of rotation, or vice versa, the larger diameter pulley will have slower speed of rotation. So that's all from the topic of angular velocity without slip. If you have some questions, then please initiate your queries and I'll be here to help you. Thank you.